In this video I want to add the deletion function to my binary heap. So how we do the deletion in a binary heap? Actually the deletion can be done via the updation. What I mean? For example, look at this binary heap. And what if I want to remove 3 from it? To remove 3 from it, I must take the leftmost node in my array. In this case, this is 100, and I must remove this node and put its key to this. Replace this 3 with the 100. Actually, I can. Then I do this replacement. I can increase this key or decrease this key or state it as the same. If this key stays the same, I don't need to do any modification. But if I increase this key, this means that I can break the constraints of the heap at this part, at the left or right subtrees. Because here all the nodes must be greater than this node, and now I increase this node, and this can lead to destroying my constraints. Okay, and that's why I need to down heapify. I can't break my constraints to the up from here. Then I go to the parents, because all the parents is less than this node because that's why is binary heap is defined in its definition. And that's why I don't need to do any up heapify. Then I increase this key. But then I decrease this key. I need to do up heapify, because I must check that some parent key is became lower than this value, this new key. And of course, if I replace this key with the lower key, I can't break any constraints here in the subtrees, because by definition all the values here is greater, and I can't. Then I decreasing this number, I can't do any violation of these constraints. Okay, because the less number is actually less than the initial number. Okay, and that's all information what we need to implement our deletion function. And let's do it. Okay, let's go. I will call my function del, and I will take its type signature from here. I will remove this thing, but not I don't need to remove this thing. So I need to know the node which I want to delete, and this is the first argument, and second argument is our container, and the return argument is not argument, and they return the container. So we have some node and some container, and we can start from some simple cases. Then we have for example empty container. This means that our length of our container is equal to 0. Okay, in this case there is nothing to delete actually, and we can return the our container. It is empty. But what if we have the length of container is equal to 1? It has only one element and we delete some element. Of course, we can remove empty element. I assume that we deleting the elements that we always put the element which contains in our heap, but better to do the checking that this element is actually in our binary heap, and that's why maybe we need to remove this type signature to maybe it's our container. But in terms of this simplicity, I will assume that n presents in our container all this. So, and now we need to check our cases. So if our new key to which we get from the last element of our array is greater than our key, in this case we can break the constraints of the subtrees, and this means they need to do down heapify. Actually, we don't need to think about this. We need, if our new key is greater than key, then we do the update our key to greater, and we have these methods for this, and this means that we can use them. So we need to update our node with new key, okay, and with some new container. So we will construct this container from this initial container, but we will replace the last element with the deleted element, and then we need to update the deletion element to greater value. Okay, and okay, of course we can have the case then our new key is less than our key, then we need to do the same thing but update to lower key. Okay, and actually we don't do the updation of not n node because we deleted it. We do the updation of some new node. Actually, this is not new node. This is the last node, I think. Last in the array node. And what if our new key is equal to our key? In this case, we doesn't need to do any modification. We can stay our container as it is. Okay, and now let's define our case and new case. So what I need at first, I can I think I need to find the key, this key. I need to define this key. How can they define it? And to define it, they need to get at first we need to get the index of this node, and we can get this with this function which takes our container and node and provides int to us. Okay, let's define it as I, and we take container and node, and we can find this I by this container and node, and then we can extract the key for this node, because they have this accessing by index function, and we know the index, and then I can get the first element, I think. So let's look. Yes, we return this pair, and we can extract the key, the first element. And now I define our key, the key which we want to delete. Okay, and now we need to define our new node and new key. Actually, this is very easy, because to do this we need to just extract the last element in our array, like this, I think, and we can unpattern match this thing into new key and new node, like this. Yes. Okay, after that we need to do some swapping. We need to swap the deleted element with the with the last element, and we have the swap function for this thing. We need to provide the indices. This is the n element index is I, and the last element index can be defined like this. And of course we need to provide the container, and this thing will define to us a new container where we swap these two things. And after this swapping we need to remove the last element, because now it is our deleted node. For removing element we have already this function extract last, so it produced to us a new container and pair. We not interested in pair, we just want a new container. So let's define something here like this. The extracting the last element from our container, new container, and here we do then pattern matching of our pair, and we will receive a new container. Here they have maybe, and that's why we need to extract the value from maybe. And of course we need to use this container in our updation. Okay, I think this thing should work. Yes, we can try to compile our module. let's load our the heap, and it's compiled, no errors. Okay, and let's try to build some heap. I think we can build it from list. With this function I can build heaps with this expression. So I paste it here. Here we'll use some another type. And they have with heap. I can transfer it to a tree, and then I can print on this tree. Sorry, print. Okay, and you can see that I have such a binary heap. This is a representation. And what if I want to delete some node from it? I can do it, easily do it with the delete function, and I need to provide a node A. I provide it, and now I can look at this modified heap. Okay, from this heap we remove the A, and what we have now, at the top we have the minimum, okay, and all nodes here is greater, and for this subtree is also we have the greater node. So I think this binary heap property, all the binary heap properties hold. What if I remove some other nodes? For example, I want to remove D, and now you can see that we haven't any D here, and also properties of the binary tree holds. So I think this function is work as expected. I don't do any testing. If you see any errors, please write comments. And thank you for watching. Push like button, push subscribe button, and see you in the next videos. Bye bye.